How's it going, everyone? Welcome. We're again. Today we're gonna talk about observables. This is a very interesting concept and also a trippy one when we need to actually is handle is incoming requests or handling is streams of data to ask the question. Because with promise we know that we can is handle the value after X amount of time. So we make so we know that by the time when that time has passed, we're gonna get that value or not. All right. But what happened when we want to actually is know for series of streams, for series of events that are gonna happen at any time in some point in the future. Streams of data. So this is now when things started to get very, very interesting and you trip a lot here with observables. So with observables here, which is now how you can combine this event and promise. As you can, so far we have looked at promise is resolved only once, all right? And the value proposition of promise is that now it gives us is this inversion control, it solves the inversion control. So we have so now we have this trust that callbacks actually eliminate that. So now with this trust of that by the time that we call or we make this computation at an X amount of time, after that time is passed, we're gonna get that. So in promise, we have now the guarantee that, hey, this won't run too many times too late, too few times, too many times too late, too early, don't swallow errors, don't lose context. But it does that only once. So, yeah, as I mentioned before, here we're going to see some mind bending or brain bending stuff here. So promising generators, if you thought that promising generator were mind bending, buckle up your seat. I'm ready. So this course is all about concurrency. So concurrency in a poor way is to coordinating of response. So managing flow control. So let's go to actually is take some notes from this particular course to understand now more in depth. All right, and let's get into
Time
this.
to move into some really brain-bending stuff. Okay, if you thought the stuff that we went over was brain-bending, buckle up your seatbelt.
So real mind-bending stuff.
Okay. Concurrency, that's what we've been talking about this entire workshop, right? What was a poor man's definition for what I meant by concurrency? Basically managing the flow control.
Exactly. So a poor way to describe is the concurrency is to managing is a flow control. That's what it is. In a poor way description is managing is the coordinating is the flow control.
Right? What was a poor man's definition for what I meant by concurrency? Basically managing the flow control, managing all
So coordinating is the flow control.
All these things that are happening and responding to things in the proper order. So we know that promises work when there's a single request and a single response. What happens when the source
Exactly. We know that promises work with a single request and a single response.
of our information that's coming is actually a repeated stream of information that's coming? Can we wire promises into an event stream, for example? Because frankly,
Exactly. A very interesting question. It all starts with a question is that because now we can with promises, we have now this request and response. Okay.
so we know that promises work when there's a single
Exactly. So we know that promise work when there is a single request and single response, right?
single request and a single response. what happens when the source of our information that's coming is actually a repeated stream of information?
Which is something, when the source of information now is a repeated source of information, sort of data, streams of data, which is something that HTTP servers, for example, actually transmit over the cable, okay? That's when we need to find a pattern to help us here. So, can Promise handle this? All right.
It's coming. Can we wire promises into an event stream, for example? Because frankly speaking, if we really look at it, most of the asynchronicity that's happening in our programs is actually event-oriented.
Most likely. So if you think about this, most of the asynchronicity that happen in your programs is event-oriented. So your UI need to respond to a request from the server, or your UI need to respond to an event from the DOM or from JavaScript or from animations or waiting for the local storage.
All of our UI is almost entirely event-oriented. It's events coming from the server, it's events coming from the user. We have events everywhere. As soon as you start trying to plug promises in, you might start to see some issues.
Block. Block. Metalworking. As soon as you start to block electrical power source, block. The drain in the sinks blocked up every so often. To connect or to become connected is to become blocked. Block. So as soon as we plug, interesting. As soon as we plug in promises, interesting. But as soon as we plug in promises here, we might start to see some issues here. As soon as we plug here, that's interesting. Stream of information. So, So as soon as we block promises here, we're starting to see some problems or some issues.
Some issues. So the server, it's events coming from the user. We have events everywhere. As soon as you start trying to plug promises in, you might.
Yeah. So as soon as you start to block, as soon as you start to block promise in, interesting. As soon as you start to block promise in, So as soon as you start to plug promise in, you'll start to see, or you might start to see, or you might start to see some issues. But this is interesting, the way how we use that verb, block. Block. Okay. Block in. So as soon as we start trying to block promise in, as soon as we started to block mouse in, right? We're starting to see some issues. We might start to see some issues.
Might start to see some issues. So let me try to illustrate that for a moment. Let's say that I had a button on my page and I wanted to represent the click of that button by way of a promise. So
I want to represent the click of the event.
So let me try to illustrate that for a moment. Let's say that I had a button on my page and I wanted to represent the click of that button by way of a promise.
Okay. Representations. Keyword here is like that. Okay. So let's say we have a button that we want to represent that's interesting. So let's say we have a button that we want to represent the click event. We want to represent is the click event.
Some issues. So let me try to illustrate that for a moment. Let's say that I had a button on my page and I wanted to represent the click of that button by way of a promise.
So let's say we have a button that we want to represent the click of that event by a way to a promise. Why is this? Because, well, promises are great for single request and single out and single response. What happens when the source of our information is now continuously sending us chunks of data, streams of data, right? So can we use promise to represent that? Okay, let's find out. Let's find out with this particular example. So here, let's say we have a button that we might to represent the click of event. Okay, let's say we have a button here that we want to represent the click of a button by way of a promise. Okay, by a way of a promise, like that. So here you're actually saying, hey, let's go into now is when you detect the click event. Here we're using is jQuery. That when you identify that target, what the French terms I can print that anyway. When you get that class name for that button, because it's going to receive that as an event, this event, which is something that I'm not quite familiar, event and MDN, it inherits from the event target, right? So the event target interface is implemented by object that can receive events and may have listener for them. In other words, any target of the event implements the three methods associated with this interface. Elements and its children, as well as document and window, are the most common target events. Okay. But other objects can be event targets too. So for example, IDB requests, audio node, and audio context are also target events. So because this is, so elements, which is element is the base class that is directly from node, okay? And then on the element you have now, and also the document and the windows are the most common event targets, okay? So hey, I want to listen to some of the events emitted by a document or a window or an element, okay? And then this is something this is something interesting, because as you can see, my bad, sorry. Sorry, I'm like a horse right now. Anyway, oh. Okay, all right. Yeah. So elements, right? Elements against children. But as you can see here in UI, we are everything here is an event oriented. We are in an event oriented world. because now we have to respond to user events or to respond to user from the server or from the database or from the animations. In this database is this local storage or IDB. So there is events everywhere, you know. And UI developers actually handle is one of the most complex topics here, right? Because a lot of this stuff you don't own that from the UI as a UI specialist. Similar as the backend developers, when you have all of the things that you don't own that. But in any case, here is this. This is the event target. So this event target implements interface is implemented by object that can receive events and may have listener for them. In other words, any target of event implements the three methods associated with this interface, right? So in other words, any target or event implements the three methods associated with this interface. Okay, okay. So any target of events implement the three methods associated with this interface, which is very straightforward. It's like add an event listener to that target, or remove an event listener, or dispatch event. So you might wonder, why am I looking at this, right? Why am I looking at the event target, by the way? You know, since this event target, it's something that is going to, so any object, okay, in other words, any target of events implements the three methods associated with this interface. So, whether it's elements, document, and window object here, many event target, including elements, document, and window, also support setting event handlers via one event property and an attribute. Also supporting setting events handlers. Setting event handlers. Events are signals fired inside the browser window that notify of change if the browser or operating system environments. So programmers can create event handlers code that will run when an event fires, allowing web page to respond appropriate to change. So this is part of the heart of the interactivity of them. So whether it's all of this target, what is a document or any element, that can be also the document windows, they implement this event target interface, which is add a listener, remove a listener, or dispatch event. And what are the available events? So events are the documents in or below the page for the JavaScript object that emits them. For example, to find out event fire on the browser window or current document, see the event window and document event. You can use the event reference to find out what JavaScript object fire events for particular APIs, animations, media, and so on. But the thing here is to recap about this event target or the event that as whoever object implement this, now you can, or whatever target implement this, it has now these three methods associated with, right? So add an event target, or add a event listener, remove event listener, and dispatch event. So here with these listeners, all right, which is indicating the type, and then the listener, and also the options or the use capture, okay. A Boolean value indicating whether the event of this type will be dispatched to the registered listener before being dispatched to any event target beneath in the DOM. Events are bubbling up towards the tree will not trigger a listener designated to use capture. Event bubbling or capturing are two ways of propagating events that occur in an element that is nested within another element. When both elements has registered a handle for the event propagation mode determines the order in which elements receive the event. See DOM level 3 events and JavaScript events order. Okay, work mode. The event order. And then you have the two model. This is capturing, and the bubbling, right? The W3 model, which has very sensibly decided to take middle position in this struggle. Any event taking place in the view event model first capture until it reach the target element and then bubble again. Okay. But you have now these two models that happen here. Use of event bubbling. Few web developers consciously use event capturing or bubbling. In web page they are made today. It is simply not necessary to let a bubbling event be handled by several different event handlers. User might get confused by several things happening after a mouse click, and usually you don't want to keep event handling script separate. It is always happen for this. And to capture events here. And uses and turn it off. Okay. We have seen early an event has a target or source element that contain the reference to the element the event happened on. Problem of the Microsoft models, and then you have discontinued. And this particular document here, work mode. Improve your CSS, hire me as your coach. I love it. Interesting. With about 20 years of experience with CSS under my belt, I can explain any beginner or intermediate level CSS feature. Get in touch. Sessions will be remote, probably whereby the using is whereby usually 2 to 3 hours in length, with as many repeated as you like. My hourly rate is not set in stone yet. I'm still figuring out what a reasonable price will be, and I'll take feedback from early clients. Exactly, whereby. That's quite interesting. Anyway. Okay. But we were just talking about is the events, right? That this event target is this interface that wherever target or element that implements that, you'll have access to this add event listener, remove event listener, and the dispatch event, right? So, all right. Why are we looking at this? Because we want to know is how can we or what will happen when the source of our information is streaming data here, right? So is promise something that we can that can help us, right? So can promise help us here, okay? So by looking at this button here, where we have this, I want to represent. We have a button that we want to represent the click events, the click of that or the click events by a way of promise. So, using my own words, we want to here we define is a button that we want to represent the click of events by a way of promise. As a way to see if we can now is somehow capture all of this stream one at a time. right? So by the time we click this, all right, we can also use. Let me actually do this, man. Let me actually go dive deep into this code because, like, open. Yeah. That's going to put it. That's going to make this. That's definitely going to make this, right? So this is now the event, all right? Because it's like this is all theoretical. No. I want to have a more hands-on approach. Event plus promise. Wait, what? Event plus promise. Okay, so here we're going to define as a button here and say button. Can we use jQuery here to make our lives much simpler? No, anyway. Well, anyway. Say button here. With the ID here, say hey ID bottom here, say bottom, okay. ID bottom here, this bottom will be is now emit, no, or click, right? So this is click, and here we say, hey, I want to now wrap this functionality by saying, hey, I want you to run this function called click, say on click, right? That you're gonna receive that event, okay? I'm going to now query that element by saying document.get element. So what I'm going to do is query that element and then attach this event listener to what next, right? To identify is that contained is a class name foo bar, and if it is, send the class name, right? So class, you say foo bar, right? So that's what we're gonna do. Get that, query that element, and then query that element, okay. Receive that target, okay. Receive that target here. Receive that event, which is now on click, MDN, all right. Because this must implement is that. This implement is the event, all right. This is the reason we're actually exploring this. So this implementing is the event, the pointer event. And this pointer event, it comes from the mouse event and the UI event. So UI events here, which is coming from the event interface, right? And the event interface represents an event which takes place on the event target. So this event base now has all of this instance property. Hey, do you bubble? Do you cancelable? Target. To select the target here, instance property, current target, okay. The current target read-only property of the event identify the element of which the event handler has been attached to that, all right. So it means that if we use the target, all right, the read-only property of the target property of the event interface is reference to the object onto which the event was dispatched. Onto which event was dispatched, and the current target. Identify the element to which the element handler has been attached. Okay, the element handler. That's interesting. What is claw here? So what is the difference between a current target and target in event object from JavaScript? Or from the web API? Event target points to specify elements that trigger the event. Point the specify element that triggered the event. The button was click, and the current target points to the element that the event handler is attached to. That's subtle difference. Why is this? Because this is bubbling. Why this is happening? Because of bubbling. To the event bubbling here in JavaScript. When the event happens on the elements, it first triggers on the elements, then bubble up through its padding, and they don't trigger and so on and so on. And there are some couple elements that bubble up. So in other words, we use the event.target to say, hey, who caused that? Okay. Event.target to point to a specified element that triggered the events of the current target that points to the element that the event handler is attached to. Okay. That the event handler is attached to. So if I say, hey, this event that is coming from the UI event, and the event in itself, it represents now this, so it's part of the web API, the event, okay, that it has all of this particular property, as well as the instance methods, prevent default, like that. So you don't want, by saying this, the prevent default, its interface tell the user agent that if the event does not get explicitly handled, it is the default action should not be taken as it normally will be, right? So prevent default. You can use prevent default. The event continues to propagate as usual unless one of its event listener called stop propagation or stop immediate propagation. As noted below, calling prevent default for a non-cancelable event, such as one dispatch via never dispatch without specifying cancelable true, has no effect. So blocking default click handler. But this is if we want, for example, prevent default won't let you check this. Because here you say, hey, by the time you now is function checkbox clicks, you click here, you say prevent default won't let you check this. Document get element by ID and event prevent default. Okay. Okay. Stopping keystroke for reading and edit files. Lowercase case letter only. Okay. So But in any case, this is something that it implements that. And why this is important? Because at the end of the day, we as a UI specialist, we are handling is all of these different all of these different events. So UI specialists live in the event-driven world. So you have now deal with the user events. You need to deal with user events as well as server events and some local storage or some animations, just to mention a couple one. And that's quite interesting. And this is the reason why it's so important to dive deep into this topic, to truly understand and to be able to describe that to others. It's like, yes, it makes a lot of sense. If you truly think about it, we live in an event-driven world, especially UI developers. So understand now not only the event target, but also that what is the event contract here? Okay. What is the event object here? What are the things that we can do here? And that is the instance property, bubbles, cancelable, compose, current target, and target. And now we know what it is about that. So the current target say, hey, get me is the element that event handler was attached to. So points the element that the event handler is attached to. And the target is point me the element that triggered that event. Interesting. Point me the element that triggered that event. Okay. Target is point me to the element that triggered that event, and the current target is that points to the element that the event handler is attached to. Current target, the event, the element that is attached to, okay, the event listener that is attached to, and the target is point me to the element that triggered that event. Why is this? Because we have bubble in this. Those are specific. So there are specific events that we can bubble up, right? Why bubbling exists? Exists for three main reasons: performance, dynamic elements, and flexibility. Attaching few event listeners via delegation use less memory and improve okay. Alright, okay. Because our click event comes from the event object, okay, from the event object, okay, from the event object. Let me actually put it this, from the event object. Okay, from the event object. So because our click event comes from the event object, and it exposes certain properties like target and current target. Just to know the difference, the first get the target that trigger that event, and current target points to, just to know the difference. The first points points to the target that triggered that event, and the current points to the event handler. You know, points to the event handler here. Points to the element that the event handler is attached to. Points to the element that the event handler is attached to. Right? So okay. Why this is important? You know, aware of events. Aware of events. Why this is important? Because event can on the target here, the event object, okay, like this, and the event target, which is the interface. But an event creating is this way they call synthetic event. An event creating in this way is called a synthetic event, as opposed to be an event fired by a browser. It can be dispatched by a script. Say, hey, new event look bubbles through and it is cancelable. Document or dispatch events. Create a look event that bubbles up and cannot be cancelled. So event can be dispatched from any element, not only the document. So, but in any case, right? As long as the implement is this event target stuff here. All right. So because events, in the case of this, right? Event target. Exactly. Event handling overview. Aware of event. Okay. Adding event listener, other event mechanism, event objects, okay. Event preventing default. Obviously this is pretty weak for validation. It would stop you the user from validate that. Okay. And then you have now the event bubbling here. So we see the web page is composed of elements here. Alright, you also see that elements can be nested inside of each other. For example, a bottom could be placed inside of a div element, and in this case we have called the div elements a padding element and the bottom a child element. So in this chapter we'll see what happens when you add an event listener to a padding element and the user clicking the child element. But again, you are adding is an event handler here on the click event, that container, and of course you're gonna click here. You click me on the div element, right? So So the reason of the event bubbling to exist, okay, exactly, because events can bubble up exactly. Why do we need bubbling? Event flow system. It is the final phase of the event propagation when the events bubble up for the target element through its ancestor in the down tree. The complete event flow has three phases: capture phase, down tree, target elements, element itself, and bubbling phase. But this particular flow of this, okay. So because events can bubble up, okay. Exactly. Why is this important? Because event can bubble up and bubbling and, and bubbling is just one part of the event flow. That's what we have here. Event flow system of the DOM event flow system. Let me actually verify this with MDM. The event flow system the system produces or fires a signal of some kind of events occurred and provide a mechanism with which action can be automatically taken. And events can fire inside of the browser window and tend to be attached to a specific item that resides in it. So, but in any case, these events that can happen in your program, okay? So because event can bubble up, and bubbling is just one of the part of the DOM event flow system, because your program can and need to detect events. All right. So the bubbling is just one of these phases here. So bubbling is one of the three phases of the event of the DOM event, of the DOM event flow system, right? So you got now is the capture phase, capture phase, down the tree, or to look at it, right? Capture phase, target phase, which is the element itself, and then the bubbling up, the bubbling phase, the up to the tree, up the tree. So why Exactly. So why do we have a event flow system? Might be silly the question. But it provides structured handling of overlapping events when elements are nested, control over event processing order, which is one of the things that we, at the end of the day, we are doing here. We are handling this processing here, this coordination here. We're managing is the control, the flow control, right? And the flexibility is where events can be handled in down hierarchy. So it is a structured handling of overlapping events when elements are nested, control over event processing, capture versus bubbling, and flexibility. So why do we have an event flow system? So if you think about it, we got a structured way to define events, or for handling overlapping events, structured way for overlapping events. Now a way to coordinate the events processing, control over event processing. So control over event processing through capture and bubble. Okay, so control over event processing through capture and bubble. Flexibility in where events can be handled in the DOM hierarchy, and flexibility where events can be handled in the DOM hierarchy. But again, is this control over event processing? So this is one of the reasons why we have this event flow system. They capture, target, and then bubble up. And my question is that why capture, target, and bubbling up exists? And why this, Why capture, target, and bubbling exists? The capture is to allow to intercept events before they reach the target. Useful for monitoring or blocking events at a high level. Important for implementing global event handling. Target phase handle events on the actual element trigger. Core interaction points to the element specific logic, essential for direct element response. And bubbling up enables event delegation and pattern handling, allows tracking related events at different levels, reduce memory use through fewer listeners. When you bubble up, you can But again, is this particularly three phases that exist, right? So capture phase, target, and bubbling phase. So the capture allows to intercept events before they reach the target. Okay, so capture this event, and then going to find that element, handle the event of the actual element trigger. Okay, allow you to intercept event before they reach the target. Hey, I detect this particular event that was triggered. and I want to go further to the element down, to the target element, where now I'm going to is response to that. All right, and then now I have this phase called bubbling here, which is, hey, enables event delegation and pattern handling, allows tracking related events at different levels for tracking events. Okay, okay. But again, why capture event bubble exists? As a way to handle that. So in any case, just to recap about this event, which is something important to understand that, right? And we want is to actually handle the silly event here, that is now implementing here, especially on click event. The click event, it implements the event object that this event object has. For example, is the current target, the target, the source, the type of this. All right. It also has some instance method that is prevent default and stop propagation. That's quite interesting. Okay. And then now to reach to the pointer event, so you have now the UI events. So UI events like, well, keyword, touch, pointer, mouse. You say, hey, mouse, touch, focus, keywords, wheel events, input events, and composition event. What? Composition events. But again, this is the most common events that we can have access to. And then you have now, for example, the detail, the view, right? It inherits from the event. So UI event is an interface that represents simple user interface events. And just to recap here, you have the mouse, mouse, touch for mobile, mouse, touch, input, keyword, wheel, right? So in our case, it's a mouse event, where this mouse event will have now the wheel event, the drag event, and the pointer event. In my case, is the pointer event. As you can see, things started to make a lot of sense here. The pointer event, where here you have now this. The pointer interface represents the state of a done event produced by a pointer, such as the geometry of the contact point, the device type that generates the event, the amount of pressure that was applied on the contact surface. A pointer is a hardware agnostic representation of input device. A pointer is a hardware agnostic representation of input device. But again, is this pointer events, right? In all of these pointer events, you have now the instance property, as well as the instance methods. So it inherits from events, UI events, and mouse events. So you have now the pointer event. Pointer event has the height, primary pointer ID, pressure, tangle. Okay, is a pointer event. Mouse event. Okay, static method, blah 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 blah. Instant methods. Okay, pointer event. This is for, this is input event. Data that a target input type is composing. Mouse event. Unless you assume that this is now a touch event. limited availability, mouse event, and then you have now the wheel drag event and pointer event. Well, now the pointer event doesn't tell you that. Where is it? Right? Where is it? On the click event. Oh, but this is events from the element. Exactly. Events from the element. But this type of event is now based on the pointer event. All right. So you have now the pointer event as it is, right? So okay, cool. This is just a way to recap this now, the event aspect. Okay, you have now the event that implement is this three methods. All right, and then you have the UI events that it can be the mouse, the wheel, the touch, pointer, input. Okay, and now this is the particular event that all elements share. Okay, so click, copy, cut, focus. As you can see, all of this, all right, which is quite interesting on the events. And let's get into this. So this is now a type here of event on click. All right, so by the time we click here, we have to say, hey, document, or even though that I will have now the element here, e dot current target, because I want to get now is the element that actually now store is the button in itself, the element that triggers that event, or the points to the elements that trigger that event. Point to the element that trigger that event. So point to the element the event handler is attached to. Exactly. So give me the elements, or this is pointing to the elements that the event handler has attached, that is attached to. In this case, click, on click. Okay. You say on click, of course, on click. I want you to now call on click. Okay. Pass that event. Store that by saying is the element. Okay, and I want to now show that on the console, say element, just like that, just to make sure that we're actually doing that. Say click, we're supposed to do this, and we are going to receive that. Type E is undefined. How can we actually pass that event to that? All right. How can we pass is the event to that? Click. HTML code. You got it. Oh, okay. And then you have now this global object like that. You say E or event. You're hallucinating, bro. Okay. 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 So you. Okay. Okay. All right. Okay. So. Okay. All right. Okay. 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 Mm. 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 So I just say is okay because we want us to query that element and then attach to that. So let me now actually query that element element by ID by saying is the button. Okay, what I have here is the button, and then because these elements implement now the event interface, I can now add an event listener here. Add event listener. Okay, that is the type of click. And once you get that, I'm gonna receive now a callback here. Where this callback is say, hey, I'm gonna receive the event, right? And what I want to do is to say, hey, if this event, which is coming from this event object, you can say something like this, console.log. Since this is an event object that comes from this object event, and in particular in the click, is now passed through the all of this property that I inherit from the UI events, and then the UI events, the mouse events, and then the pointer events. So I can have access to this. So by the time you do click, I'm gonna get access to that. All right, it's process and blah 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 blah. So this is now to say, hey, give me the target element. Okay. You say, hey, event target element. I mean, is current target. Okay. Give me is the element that I points to the element that have an event listener attached to this. And in this case, it'll be this button. Exactly. So point me to the element that have an event that had an event element attached to this. In this case, the button. So now here we can say, okay, since we have now our button here. Okay, this is our button here, and we want to now get is the class and check if that class exists. You say, hey, it's gonna say is now a class name here, right? Here, I receive this HTML as a string, okay, and then I want to verify that, hey, using a regular expression by say, I want to verify is the foo bar the text, right, exists on the class on class name, right? And if that exists, all right. So good. So if that exists, well, I want to now send something like this and say, hey, resolve. Or say something like this, let's say, hey, console.log return the class name. You say, return the class name. Otherwise, nothing, right? Otherwise, do nothing. But that's great. Okay, that's good. So when we click here, we clear the console here. We click here. It say no, it doesn't show anything here. Full bar. Oh, because I need to get is the if I use a target here, which is the element points to the element that trigger that event, okay, points me the element that trigger that event, that target dot class name, okay. You got full bar, right? As you can see, the target now is the element. So target here on the event property is now the event. It return is the associated value of the event target. Okay, and this event target now it has that. To the parent UL in this context. It is different from the event current, where the event handler is called during the bubbling or capturing phase of the event. The current dot targets when the event handler is called during bubbling or capture phase of the event. Okay, I don't want to call this during the event. Okay. It's because it's calling during the event bubbling here. So unlike current target, it is called during the capture and bubbling. During the capturing and bubbling event. Makes a lot of sense. Makes a lot of sense. Okay. So current target is called during the capturing and bubbling event. It is different from current target when the event handler is called during the bubbling phase of capturing the phase of the event. So it is safe to assume that the bubbling effect here that target, unlike current target, it is called during capturing bubble event. No, target always refers to the element that initiates the event, regardless of the phase. The phase doesn't affect what target points to. It stays constant through the event flow. Only current target changes during event propagation to reflect the current element whose listener is being executed. So the target refers to the element that initiates that. Okay. So target refers to the element that initiate that event. That initiates that event. Makes a lot of sense. Okay, makes a lot of sense. So target refers to the element that initiates that event. Makes sense. Makes a lot of sense. And current target changes during event propagation to reflect the current element whose listener is being executed. Exactly. And current target changes based on the current phase. Unlike current target, it is called during capturing. Exactly. So current target, it is called during change during event propagation to reflect current element. Change during event propagation. Okay. That's one of the reasons why we're actually using target and not current target, because current target changes during event propagation to whoever listening is attached to. Change based on the current phase. Okay. So in this case, it will still continue to work. You click here. It's called foobar. That's right. So the whole point of this, if we want to simulate now, is let's see if we can simulate. Let's see if we can now. Let's see if promise help us here to handle this streams of data. So we can say something like this. Say, hey, the promise. I want to create now a new promise, right? And then attach that to that. Say P1, right? I'm going to create a new promise where this new promise stuff here, inside of this, it will be the executor function, right? Based on their documentation, they call that executor function. Okay, this is just for an academic sense to understand why they call that. But this is what we're gonna do here, right? And because this executor receive now is to functions from the callback, all right? Hey, to say, remember, the promise is just a placeholder that is an idea that we need a placeholder to eliminate time as a complexing factor by wrapping a value around it. So that's what we have here is the resolve and reject, because by the time that promise was resolved or rejected, okay, after an X amount of time, this is what I want you to now handle for me, or reject here. So say, hey, I want you to now is, well, pass that to the class name. Okay, so this is good, right? Otherwise, well, it's going to now reject this. Reject with nothing. No. And then you say, all right, we can do this, right? Pretty straightforward, silly as well. Well, now we're going to call our promise. And by the time we subscribe to that, by the time we get that value, which in this case will be immediately, or after the JavaScript evaluate all the synchronous code, and then tell the event loop, hey, do you have anything in the micro task? Yes, please pass that to the call stack, evaluate until exhaustion, and then go to the callback here. So we do this, right? So p dot then we're gonna get now the value here in this case will be the class name, and we can get just console log at that class name as it is, right? And that's pretty much. This is it. We create a promise, and then we subscribe to the promise for that. And say, hey, there is a problem here. missing before class body. Oh, it might be here or here. Oh, it's good. Element clear listener. That's right. You're handling that properly. And then you say this is a P1, right? P1 return this. And say class name. Missing. Missing before class body. Missing. Am I not looking at that properly? Say console log. Class name, right? Okay. What about now? Then you go 4. But again, this only works once. So how to handle streams of exactly what is promise is promises or can promises help us to deal with data? Yeah, so can promise help us to deal with data can help us to deal when the source of data send a continuous data. Can promise help us to deal when the source of data send a continuous information? All right, in this case it only works once. It only works once. Right? So you can also see something like this. Say, hey, but I can't do something like this. Then I can subscribe to another one. Say click one. But it only runs once. It only works once. That's what happened. So you can say here H1, right? H1 and H1 here. Event plus promises. Say promises, right? Event plus promises. You say now the diff. Say ID. Then you say output data. Say output. Right. You want to show something here. And by the time you do this, you say, hey, well, I want to handle this as it is. Yep. I want to handle this as it is. It's like say, hey, document get element by ID. Okay, you can define some output function here. Hey, this will be now our output. function called output here, output. We're going to receive that data, and then it's going to now output that data as expected, right? Say, hey, document get element by ID, output, right? And then you attach that to an output element, right? Not only that, by the time you attach that document get element by ID, output, yeah, this is the output. So output, I want to now attach this, say output dot text content, because this is, after all, is now a text node or a node, all right, that has that particular property that inherited from that, the text content, and you say, all right, print out with the data. So here you only do is this, say output, because actually it has the same signature. This is known as the point free. By the time you call this, actually show this as full bar, right? It's gonna make this, say, break line here, and let's gonna make this in an H2, right? And here you say, so what is the class name of this button? All right, you click here, you say full bar. So a very silly example here, you know, a very silly example, but it only works once. You know, it only works once. You can say something here to say append child, right? Append child here by creating now a new element here and say create a paragraph. Say, hey, I want you to create this element document, create element as it is, right? Just now a paragraph. In that paragraph, I want to now attach the text content. You say, hey, p dot text content. That'll be the data, and then I want you to append that child as this, right? So this is it, and you got it. But it only works once. So it only works once. So unfortunately, it only works once. But it only works once. So, okay, that was interesting. That was good. Again, what is the next stuff here?
So I already know I can construct a promise like I'm doing on line 1, and I can set up my click handler inside of it. So I have button.click, and I'm doing some extra logic just to illustrate that there's extra steps that we might do. So I'm going to test its class name, and if it matches that regular expression foobar, then I'm going to resolve the promise. Otherwise, I'm going to reject the promise. Okay? And then down somewhere else in my program, line 13 represents a different place in my program. I'm going to respond to that promise by printing out whatever was clicked on. Now, the spirit of this is that every time I click on the button, I'm going to get either that I printed it out, or if I clicked a button that, I'm going to print out a class name if it matched foobar, but if I clicked a button that didn't have that, nothing would happen. That's the spirit of it. Does anybody spot a problem with this code?
It only runs one.
What?
It's only going to fire once.
Promises can only be resolved once. So the very first time you click a button, whichever button it is, it's going to resolve or reject the promise. And every time else, when you click the button, nothing's going to happen. Right? Uh-oh. What do we do?
Okay. So is this. So we got now this one. All right. So problem is only resolved once. Example here. Right. So problem is only resolved once. So you might think is like,
How do we use promises? We've built ourselves up to promises and generators. We've given ourselves several layers of higher order abstractions. But now we're faced with an extremely common thing that's going to happen in our programs, that is responding to events, repeated things that are happening, and all of a sudden promises seem to fall apart. What do we do? Well, one thing you might do is to invert. You might say, instead of creating my promise and then my button handler inside, do it the other way around. Make my button handler, click handler, and then create a promise inside. What's going to happen here is I'm going to get a whole new promise for each event that's fired. That sounds great, right?
That sounds great, but...
Except, why?
Why?
Because once the event's already been fired, then what's the purpose of the promise here, right? You see what I'm doing? I'm immediately resolving a promise, and then immediately calling a .then on it.
Exactly.
How much sense does that make? There's something even deeper, though. Because what we've really done when we inverted, we made that little simple trick where I inverted it and I did one inside the other instead of the other way around. Now we have conflated our separation of concerns. In the previous code, subtly, I was able to set up
that we are
my source
conflated
in one location.
We are conflated.
There's something even deeper, though. Because what we've really done when we inverted, we made that little simple trick where I inverted it and I did one inside the other instead of the other way around. Now we have conflated our...
We have conflated, man, which is exactly here. So another thing, so because all that we can say right now, let's make a promise to subscribe to the same function. So one thing you can do is to now define them inside of the event listener, right? But the question is why? Because we have we have now conflated. I am so conflated. I am conflating the source and the subscription all in the same spot. So not only that you have to jump over a whole bunch of hoops to get a promise out of that event, because that will happen here if you define this particular logic here, like so. So you'll have to define all of this, and so you have to go through over. You will have to go through series of. You will have to go. Okay, you will have to jump over a whole bunch of hoops. So you will have to jump over a whole bunch of hoops to get your promise out of that event. Especially here, because we conflated is now the source and the destination, the source and the subscription of data.
Separation of concerns. In the previous code, subtly, I was able to set up my source in one location and have my response to it. I was able to subscribe and have my source to it in a different location of my application. Those are two separate capabilities. But when I invert, guess what's happened? I have to set up the source and the subscription all in the same spot. So I've conflated those two responsibilities together. And you're going to have to jump through a whole bunch of hoops to get those promises out of your click handler. Every time you fire it, if you need those promises to respond in other places, you're going to have to save them off into some shared closured variable or something.
Most likely, yeah. You'll have to save. So if you, especially if you want to get out of your promise out of this, you will have to pass through a whole bunch of hoops. A whole bunch of hoops to get your promise out of this, and then you then will need to define some sort of closure to actually save the state of this promise
And all of a
and
sudden,
then
you're
we
gonna
all
be
of
way
a sudden we
right back at
begin
the beginning.
we're
all
right
the
back
same
at the beginning.
problems of weirdness and hard to understand.
We right back at the beginning
So
with the same problem.
right off the bat, we see that promises, at least by themselves, are not going to model well in an event-oriented world. We're going to need something better. Now, you could observe that actually that wasn't fundamentally an asynchronous set of steps anyway. And we could go back, we could fall back to things that are a little more familiar to us, like a list context, where I put my event into an array as I'm doing on line 3, and then I call maps and reduces and filters. And you might go back to a synchronous programming mindset and say, oh, who cares about the promise? But we've still fundamentally got an inverted system here, where the response to the event has to be conflated with the setup for the event. So we have producer and consumer in the same spot.
So one of the issue with this is, so we can go. So promises here are not going to help us. So we can get rid of them and go with something that is more familiar with us, with us. Like the event, like list context, right?
And that's not what we want. We need something to bridge the gap so that we can separate those concerns. Enter.
Okay. However, we are still here conflated the source and destination in the same spot. So we need to keep those concerns separate. Why? Because we want to have the ability to create or to set up and consume data, to set up and consume chunks of data from the from our source, So
Observables.
enter observables.
Now, understand that observables are not a guarantee for JavaScript. Right now, they are implemented in user-land libraries, and there is a proposal for observables to land in the language. At some point, there was a strong feeling like they might land in the ES7 timeframe. As far as I'm aware, I don't think that's actually going to happen in ES7, meaning ES 2016. Because as far as I'm aware, as of today, I think the feature cutoff for ES 2016 is like next month. So observables are on a good path, and there's a pretty good chance we're going to get something like this natively in the language. It just might not be next month, so it might be a little bit further off. And that means that what we're about to learn with observables, we're learning based upon the semantics of a particular library implementation. We don't have a very good sense of exactly what they're going to be from a native primitive perspective like we did with promises. So the caveat here is the sorts of stuff that we're about to talk about is subject to some flux. It's subject to some evolution. Between now and the time that some final standard lands, observables may end up being called something different. They might have a different looking API. Who knows? But right now, there's a pretty good library out there for observables, and it's called RxJS. That's our JavaScript library. It's actually, Rx is the name of the library, Reactive Extensions. It's made by the folks, really smart folks at Microsoft. And they've ported it to like a dozen or a couple dozen different languages. So RxJS is the JavaScript port. It's in C#. I think that's the original one. It's in Java. It's in several other languages. So it's nice from the consistency perspective. Whatever language you work in, there's probably an Rx library for it. Once you learn it once, you're going to be able to use it in lots of places. That's good. But to understand what an observable is, again, from a conceptual perspective, see how this is how I always teach. I'm not going to teach you the API first. I want to teach you the conceptuals. So let's talk about spreadsheets. Everybody loves spreadsheets, right? I just found some random spreadsheet image on Google Images because I didn't have any good ones to take of my own. I don't know what this spreadsheet is, but it's pretty clear that this spreadsheet is illustrating the concept that I want to get across. By the way, this metaphor is not unique to me, so I've heard this from others. I just think it's a particularly good one to start with. An observable is kind of like a chain of calculated fields in a spreadsheet. So, in spreadsheets, you can have data in a field, but you can also have a field which is a calculated field. It's calculated based upon the data that's in some other field. So C1 might have the number 10 in it, and C2, right below it, might be whatever value is in there times 2. So when I type in 10, then as soon as I hit enter, immediately this field says 20. And I might have another field over here, I might have D13 that says D13 is the calculation of 3 times whatever's in C2. So I change this to 20, C1 becomes 20, C2 becomes 40, and D13 becomes 120, right? Do you see that the calculation chain is a flow of data? We're setting up a flow of data from an original source location to all these different places where we're doing something with that data, we're calculating something, we're subscribing to and responding to that data. That's the genesis of this notion of reactive programming. When we think about reactive programming,
this is when we don't own
the source of my data is some event source. But the data, once I get that event, it's going to go through a series of steps, and some of those steps are going to be direct, like responsive, just calculate something, and some of them might be asynchronous steps. The calculation of the data that goes through the spreadsheet as you change one value, even though it looks immediate to us, each step it has to update all the fields and then update all the fields and then update all the fields. So there is some propagation delay, if you will. But we can think about an observable, or rather reactive programming, as a way to model a piece of data coming in one side, that's from the producer, the event emitter, if you will, coming in one side, and all the steps that it takes to propagate its way through a system. It's a data flow mechanism. And data flow mechanisms are built from the ground up to respond to events. So if we've got event-oriented systems, this might be a really good abstraction for us. Does everybody follow where I'm coming from conceptually? So let me boil this down for you. An observable is an adapter hooked on to an event source that produces a promise every time a new event comes through. But it does so in that separate way where I can set up my event source, and an entirely different part of my location, I can declaratively say, what's my data flow? I don't have to conflate the two like we were doing in those other examples where I put the promise inside of the event thing. I have an observable that represents my data source, and I can subscribe to that observable in one or more other locations of my system in an entirely separate way. And it's going to magically take care of all that creation of promises and the bridging the gap for us. So it's a way in programming to represent what we can visually think about, or conceptually think about from a spreadsheet. We can represent each one of those different fields as a different step in a chain of response to an observable. So here's a quick example of some code from RxJS. You'll notice that you create an observable using rx.observable.fromEvent. That's one of their many utilities they provide. And the way it's set up is it takes a DOM element and an event name. It automatically hooks the event name to the DOM element, and every time one of those events fires, it pumps another piece of data through the chain, through the observable.
Through the observable.
So that's how we create an
observable
from an event.
Through the
There's
event.
about a dozen or so different ways to make an observable. You can make one by attaching it to an event. You can make a plain old simple observable that you manually are going to pump some data through. You can attach it from a website. I mean, there's a lot of different ways to make observables. But I make an observable on line 1. In an entirely different part of my system, I can declare what all those steps are, what all the calculations of the fields in my spreadsheet look like. Basically, I make a declarative chain of the data flow.
Exactly.
So every time an event comes
a declarative
in
chain
from
of
the
the
DOM
data
event,
flow.
every time I click on a button, that's a piece of data coming in, and it's going to flow through
Is each
chain.
one of piece of data
Now,
that comes
we have
here.
utilities that look familiar to us, like map. Map in the synchronous sense went over a whole array of values. Map in the asynchronous event is just invoked every time a new piece of data comes along. So you can actually think about an event stream as a never-ending array. And we can perform the same sorts of list operations across time that we would do all together. That's why it was important for us to understand maps and reduces and things like that. So here we can map over an event stream in much the same way conceptually that we could map over an array that was already complete. It's just that every time a piece of data comes through, we can do some sort of transformation on it. And here the transformation is I'm extracting the class name from the event object. We can filter down, we can perform an exclusion on our list. And that's something interesting, because fundamentally this list is actually asynchronous. We can actually have steps in our response that are asynchronous, distinct until changed. It's an interesting one. What it says is, the first time a piece of data comes through, let it go through. But if another one comes through with the same piece of data, don't let that go through because I've already seen that one. But then if something new comes along, let that one through. And if I keep getting the same one of those, don't let any more duplicates come through. So let's say I have one that the number 1 comes through the system, and I got 5 of those. Only the first one's going to be let through, and the next 4 are going to be ignored. And then a 2 comes along. So I'm going to let the first 2 come along, and any duplicates are going to be ignored. What happens when another 1 comes along? I'm going to let one more 1 come through, and then ignore any duplicates. That's what the until changed is. So there's distinct, which is just, I only want 1 ever of the thing, and distinct until changed is distinct, and then I reset. Every time a new value comes in, I reset what I'm remembering. So you notice in this chain, not all of my events are going to make it to line 11. And that's totally okay, because we're setting ourselves up with a data flow, just like we would in a spreadsheet. Subscribe is kind of like the end of the chain. Subscribe is how you basically have a sort of synchronous response to any events that are coming in. So there's more to it than that. But you notice that basically subscribe is kind of like a synchronous thing. I'm not transforming any data. It's not really going to show up in the middle of my chain probably. It's kind of going to be at the end of my chain. It's when I am finally done with whatever the data is, through all of its transformations and filterings, I arrive at some data. So at the end of my chain, I have a subscribe, I have a piece of data that comes in, and I can console.log it out. Okay. So that's a real high-level view of what working with an observable is like. We have to make an observable some way, and we have utilities and libraries that can do that for us, and then we have to respond to observables. And it's appropriate, I think, some people disagree with this, but I think it's appropriate to think of an observable as a stream. It's a stream of data that's going to come through. It's being pumped by a set of events, and it's a stream of data that's
But you define the setup? Did you define the
source?
What
about distinct until changed? I actually want you all to pop this up. You have in your slides a link, or you can just type it. I love this website, rxmarbles.com. Let's all take a look at rxmarbles.com. I just get such a kick out of this website. Let me quickly orient you. Go ahead and click down on the distinct until changed, which is just slightly down the list there on the left. Click on the distinct until changed. And you'll notice that it's depicting for us with these marbles, these little bubbles here, kind of exactly what we're talking about. The stuff on the top is the input, and there's only one stream for this. And the stuff on the bottom is the output. And you'll notice what happens as I start to move these marbles around. What happens if I move this one over here? You notice how it just disappeared? Because the sequence meant that it was just a duplicate. So we can move the marbles around and see how these different stream operations operate. We're going to come back to Rx marbles and look at more stream operations in a little bit, but you can notice that probably about the top, I'd say maybe 30 or 40 of them are depicted here. Rx actually has probably like 150, maybe 200 different methods. It's a pretty big library. All told, if you got everything, I think it's something like 150, 200K of JavaScript. So it's a pretty stout library. It takes a while to learn all these things. I have not found any other resource on the web that is better at learning than Rx Marbles. I think you can probably learn 50% of observables by doing nothing but just playing around with the bubbles on the screen. It's a really fantastic resource, okay? Helps you visualize what's happening with your different stream operations. So we'll come back to distinct until chained. I mean, we'll come back to Rx Marbles here in a little bit, but I just wanted to point that out to you. I did say that RxJS is pretty well standardized. It's a really good idea. It's probably a pretty good sense of what we're going to end up with, or something very close to it, if we get observables in JavaScript. I've tried a number of times to learn RxJS. Honestly, I have. And I've never had enough time to get through all of that documentation, the training courses I've gone through. It takes a lot of effort. And comparatively speaking, if I try to analyze the asynchronous event-based coding that I...
Okay. So that'll be all for this video. Take care. Bye-bye.